All right, I just gave back some homeworks. It was some exercises for doing textual substitutions and quantification. Everybody did really well, so I don't think we need to go over that. Now today we're going to do, we've got a lot to do, and we are going to do, if you'll notice that one of the things that you have to do for your next homework assignment is to practice doing a proof, because this is one of those rare occasions where I will tell you exactly that this proof is going to be on the exam, so you can count on it. It's not just a probably, it will be. So when we do this proof later on in the lecture, you'll want to pay really close attention to how it's done. But we have, before we do that, we want to continue our, doing our examples. We have one more example to do of one of the axioms. And the one that we're going to look at is 819, interchange of dummies. All right, so let's take a look at 819, interchange of dummies. Let's take a look at what it says. What happens in 819, you'll notice the structure. On the left-hand side, we have a quantification nested inside the body of another quantification. And what's the difference between the left-hand side and the right-hand side? Because on the right-hand side, we also have a quantification nested in the body of another quantification. So what's the difference between the left-hand side and the right-hand side of 8.19? Hello? Anybody out there?
The ranges are switched.
And not only are the ranges switched, yeah, the ranges and the dummies are switched. Okay, does everybody
Piece of cake.
Does everybody see that? So what this says is that if you have a quantification in the body of another quantification, you can actually take the range and the dummy and you can move it to the outside, and you move the outside to the inside. But you can't do that 100% of the time because there's a proviso. You can only do that provided something is the case. And what does it say? It says provided that star is idempotent or R and Q are finite. Okay, so provided. And also provided what? So this next one is really crucial. Provided what? How do you say not occurs Y in R? Y doesn't occur in R. So what is Y? Y is which?
One of the dummies.
Y is the dummy. It's the inner dummy on the left-hand side, and it cannot occur in the what?
The range.
In the range of the outer one. Are you with me? Now, why do you see why we need this proviso? Why is it that Y cannot occur in that outer R? Okay, let me ask you a question. If Y did occur in that outer R, would it be bound or free? If Y occurred, this R is an expression, yeah? If Y occurred in this big R on the left, would it be bound or free?
Free.
It would be free. Yeah, now come on. Yeah, oh my goodness. Remember, we got to get this concept of bound and free. Okay, yeah, you were just guessing, huh? Okay, well, let's not guess. Let's think. Look, if Y, this big R, capital letters mean what? Expression, right? So it has a bunch of Boolean stuff, operators, infix, blah, 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 right?
Yeah, so.
And variables. There could be some variables. So what if one of those variables in R was a little y?
It would be free.
It would be free. Now, I hope, is everybody clear on that? Why would it be free? Because it's not this x. Because this is x. Are you with me?
Free just means it's not in the dummy, basically.
Well, it's not in this dummy, right? Okay. So if Y did occur in R, it would be free, right? If it did occur in R, it would be free. But look, if we switch it over like this, on the right-hand side, if that y is in R,
Become bound.
it would become bound. And so that wouldn't work because it would be free in one case and bound in the other, and those things wouldn't be equal. It would be a different y. Are you with me? Is everybody clear? It would be a different y. So that's why we have that proviso. That's why. And similarly, the other way around, right? So the other proviso is that x cannot occur in Q. Because look at the right-hand side. If x were in Q, would it be bound? On the right-hand side, if x were in Q on the right-hand side, would that x be bound?
No.
It would not be bound. But on the other side, if there was an x in Q, would it be bound?
Yes.
Yeah, so, you know, those would be two different x's. So you'd be, you know, it would be a different, you can't do that. The only way you can switch this is if y is not in R, is if the inner quantity, on the left-hand side, if the dummy on the inner one cannot be in the range of the outer, and similarly, on the right-hand side, the same thing, all right? So those are the provisos. Now, this, you know, we did a lot of writing last time for all of these examples. And so to save writing time, what I've done is I've given you a little, what we're going to do is this next example. Okay? And just so that you can save your, send those around. I have a little worksheet here, okay? And just to save us some writing. And what this is this is an example. What we're going to do is we're going to work our way through an example, okay? And so now you can just take notes on this sheet. This is fill in the blank, all right? So we'll go around the room. So you still have to contribute to the discussion, okay? And let's take a look at this example. So look at the very top line here. What we have on the top line is star x over r, body, star y over q, body p. Okay, so, and then equals star y over q, body, star x, range r, body p. Right? So that is just a statement of what it is that we're going to illustrate with this example. All right? Now, for this example, we are going to use, for r, we're going to use the range 1 less than or equal to x less than 4. So tell me, what are the possible values of x that we have in that range? What are they?
1, 2, 3.
1, 2, 3. Is everybody good? Okay. And for q, what are we going to use?
8, 9.
8, 9. Is everybody clear on this? Okay. And for p, the body, we're going to use 6 times x times y. All right. So that's going to be the example. So now, does everybody see that y does not occur in 1 less than or equal to x less than 4? Are you with me? So, and also x does not occur in 8 less than or equal to 9 less than 10, right? So our provisos hold, you know. So we can do interchange of dummies. Now let's do an example, okay? So Josh, since you're so good at spelling out all of this stuff, what we're going to do is we're going to start with the left-hand side. And the example is going to be plus over x, range r, body, plus over y, range q, body, 6 times x times y. Now, in the first step, what we're going to do is we're going to expand the inner quantification. So can you tell me what this next line is going to be?
Parentheses plus x,
Plus x.
range y,
No, range. Range r, body.
parentheses.
Well, now, body. Now let's now let's expand it out.
All right.
Okay, so now we're going to expand that out. So how do you expand out plus y, range q, 6 times x plus y? Well,
6 times 1 times 8 plus.
no.
6
Just
times
no. Just over y. Just over y.
Wait, what?
We're just going to expand this over y. We're going to expand the inner quantification. We're not going to expand the x. We're just y. So what are the possible values of y in Q? What are the
6 times x times 8 and 6 times x times 9.
Okay, is everybody clear?
Very.
Okay, so expanding that out, it's sum on x, range r, 6 times x times 8 plus 6 times x times 9. That's expanding the inner one, right? Okay, so now Mason, now what happens if we expand this one? Okay, so this is sum on x, range r. So what are the possible values of x in range r? What are they? 1, 2, and 3. So we have to write this down with x being 1, and then x being 2, and then x being 3, right? So can you say it really quickly?
So it's 6 times 1 times 8 plus 6 times 1
plus 9
plus 6 times
2 times 8 plus 6 times 2 times 9
plus 6 times
3 times 8 plus 6 times 3. Good. Now you see why all right. Is everybody clear on that expansion? Yeah? 6 times 1 times 8 plus 6 times 1 times 9 plus 6 times 2 times 8 plus 6 times 2 times 9 plus 6 times 3 times 8 plus 6 times 3 times 9. All right. Now, Kale, now what we want to do is we're going to use symmetry to regroup these. Now, do you see how we want to do the regrouping so that when we quantify, it will be we will have exchanged the quantifications. Do you see how we will want to regroup them?
6 times 1
Times
times
8.
8, 6 times plus 6 times 2 times 8
Plus
6 times
3 times 8 on the one hand, and then plus what?
6 times
All the
2
nines.
times 8 plus
No. 6 times
6 times 1 times 9
9
plus 6 times 2
times
times
9.
6 times
Yeah. So is everybody, are we good?
Yeah.
Yes.
That's what I wrote out.
Good deal. So you are anticipating this. But now comes the tricky part. I think it's a little bit harder to go the other way. Now, Ben, what we want to do is quantify over x.
Okay.
Now, what are the possible values of x?
1,
In our r, what are the possible values?
2, and 3.
Yes, 1, 2, and 3. So how would you quantify this left-hand one over x?
6 times x times 8.
No, it's parentheses. We are quantifying.
Parentheses plus x.
Plus x, range what?
Over-
Wait.
Yeah, range.
Range what?
1 is less than or equal to.
Yeah, let's just say
x less
r.
than 4. Yeah,
Yeah, r.
something.
Okay, range of r. Okay. And then what's in the body? Body what?
Is, 6 times x times 8.
Okay, body 6 times x times 8 for that one. Right? Now what about the right hand? What about the next one?
Plus x.
Plus x,
R.
r,
body-
range r.
Range r. Body 6 times x times 9.
Okay. Is everybody good? All right, is everybody, see, are we good for this?
Wait, why do you so you have to make it 2 quantifications?
Yes.
That's
Yeah.
annoying.
No, this is illustrating how we're going to exchange. Yeah?
Okay.
So, and you see how we did, yeah, you see how we quantified this to here?
Yeah.
And then you see how we quantified this to here?
Yeah. Yeah, I forgot that we were doing the kind of the dummy switch.
Right.
Otherwise,
Now-
I'd be going backwards, just doing the same.
Yeah. Okay, and now, Kyle, how do we take this and quantify over r? So what are the possible values of, here, it's over y. So what are the possible values of y in Q? What are they?
8 and 9.
8 and 9. Okay, so what do we have here? 8 and 9, right? So this is what, are you with me? This is 8 and this is 9. So this is what?
Plus x.
Sum
Sum over x.
Sum over, no.
Sum over y.
Sum over y, range, Q, body,
Sum over x.
sum over x,
Range
r,
6 times 8 times y. Or 6 times x times y.
6 times x, yeah,
Done.
boom. Are you with me? Is this clear? See?
Crystal.
And look, and isn't this slick? I mean, so what this says is that you have the x here and the y here. Oh, here we have the y here and the x here. But the only reason we could do it was because we didn't have those, well, yeah, it has to be an abelian monoid, which is what? Abelian means what?
Has my density, it's symmetrical.
Yeah, but what does the abelian part mean?
Symmetry,
Symmetry. Abelian is symmetry. And then the monoid is what?
identity, and
Associative and has an identity. Okay. So it is, and plus is an abelian monoid, so this, all of this stuff works, all right? And will I ask you ever to prove axiom 8.19?
no possible.
No, but this is an illustration of how it works with addition, with the addition operator. All right, are we good? Okay, now, for the next axiom, we have to review a little math, okay? Do you guys remember how inverse functions work?
Yep. 6x and y.
Okay, inverse functions. Now let me start with an example before we do the general one. Suppose we have, now, so we'll just use this math notation, f of x is x squared, right? So everybody's familiar with a function that would look like this. This, if you were to graph it, it looks like a parabola, whatever, right?
It is a problem.
Yeah, it is a parabola. Well, the graph, yeah. Okay, it doesn't just look like a parabola, it is a parabola, right? Now, and in fact, if you do graph this, what you normally do is you have an axis and you have y-axis and the x-axis, right? And so f of x, so f of x is the y, right? So this is y equals x squared, right?
Yep.
Now, suppose I ask you to solve this for x. So y equals x squared. This equals by solve for x. What does this equal?
X
Square root of y.
Yeah,
plus
x.
or minus the square root.
Yeah, let's just ignore the
Plus or minus
the plus minus bit. Okay, so this is x equals square root of y, right? Are we good?
Shut up. Oh, what up?
Okay, so
We've doubled the across the table.
okay, so now using our using our dot notation, this is y equals f dot x, right?
Yeah, sure.
Are you with me? This is y equals f. Now, on the other hand, what is x? How do we notate this? Have you ever seen this? Have you ever seen this? Have you ever seen this? If f of x is x squared, then what is f inverse of y? Now, this minus 1 does not mean 1 over.
No, yeah.
Is everybody clear on that? Like if you do sine negative 1, that does not mean 1 over the sine. That means the inverse sine.
Just the y and x, it could be y equals radical x.
Yeah, so f inverse of y is what?
Radical
Radical
x.
y. It's a function of y. So this is the inverse function, right?
Sure.
Is everybody, we have to, okay? And so the way we would use this using our dot notation is we would say x equals f inverse dot y, right? And the main thing to remember is that when you use a little exponent to the minus 1, it does not mean 1 over. It means the inverse function. And I think you guys have all had trig, so you know sine minus 1, that's the inverse sine.
Is that bottom in first row?
Yeah, because this is the inverse function. See, if the original function is x squared, then the inverse function is the square root. So the inverse function is a function of y.
We'd only write
Are you with me? The inverse function is a function of y.
x equals square root of x.
Now, what is the key property of the inverse function? What happens if I take f?
If the range
of, now watch this. What happens if I take f of f inverse of y?
Equals y.
Yeah, it should be, but let's work it out. Well, so this is f of, so now what is f inverse of y?
Square root of
Square root of y. So this is f of the square root of y, right? But what is f of anything? It's what? That thing what?
Squared.
Squared. So this is the square root of y squared. But the square root of y squared is y. So we have f of the f inverse of y is y. But it also works the other way around. What happens if you have f inverse of f of x?
X.
Well, yeah, it's the inverse function of, and what is,
square root of x squared.
yeah, this is x squared, okay? So this would be the square root of x squared, which would be x. So it doesn't matter which way you do it. If you have a function of its inverse, or you have the inverse function of the function, what do you always get back? The what? The variable. Yeah? So that is the definition of inverse in general. So now here's what we have to know for our next proof. This is definition of inverse. Okay? The definition of inverse is this. Y equals f dot x equivales what?
X f inverse dot y.
Equivales x equals f inverse dot y is correct. Are you with me? Does everybody see that this is the definition? Or you can switch the roles of x and y, or
Can't you switch them on just one side?
or switching the roles of x and y. Another way to write this is x equals f dot y is equivalent to what?
Y equals f inverse.
Y equals f inverse.
Can you switch the roles on just one side?
No. Notice here that the f of f inverse of y, and here we have f inverse of f of x.
We would just write back in math class, we used to just write the inverse function as f inverse of x equals the square root of x.
Well, any time for any inverse function, anytime you do f, I don't.
Because you're just renaming the variable. You're like,
Yeah. Here, yeah. F inverse of x is the square root of x. Yeah, you can whichever way you want to do it. It's fine. Okay. So now does everybody understand this? Everybody see this?
Sure.
So the minus does not mean divided by. Okay. And so now here, let's do one more example before we actually do the proof, the big hairy proof. Okay.
We're going to do nesting or dummy renaming.
Okay, so here's one more example. Here's another example. This is make sure you can do we can do inverses. Suppose that f dot x is 5x plus 7. Suppose f dot x is 5x plus 7. Then how would you get the inverse? Well, you'd say y equals 5x plus 7, right? And you'd say this equals by solve for x. So if we solve for, can you do this really quickly in your head? So
y minus 7 over 5.
y minus 7 over 5. So x equals y minus 7 over 5, right? So in this case, f dot x would be 5x plus 7, and f inverse dot y would be y minus 7 over 5. And notice that it's not 1 divided by 5x plus 7, right? That's just to make sure that when you have this negative 1 here, when you're talking about inverses, it doesn't mean 1 over. Huh?
What's the point of this?
The point of this is the following.
All right.
Glad you asked. Oh, by the way, let's just take, before we, well, the point of this is look at what 8.22 says. Change of dummy, provided not occurs y in R and P, and what? F has an inverse. To prove this, we're going to need to use the fact that F has an inverse with these properties. All right? So that's the point of it. Okay? Now, before we actually do that, let's just take a look at 8.21 very briefly. 8.21 is an axiom called dummy renaming. But you know what? You guys already know how to do this. Because I just handed back a homework exercise where you had to do dummy renaming. We've done exercises with dummy renaming. And we know the concept of you can name it whatever you want. Yeah? So how do you do dummy renaming? How does this axiom say that you do dummy renaming? If you want to change it from X, if you want to change the dummy from X to Y, you just, instead of doing star X, you do what?
Star Y.
You do star Y, and in the range, everywhere there's an X, you replace it with Y, and in the body, everywhere there's an X, you replace it with Y. So yeah, that's just that.
You can sub in a function too? The next one.
Oh, yeah. Actually, here, let me give you, before we do the actual proof, let me give you an example of 8.22. Yes, in fact, let me show you how that works. I think it's pretty good. Let's do an example of 8. Yeah.
We don't have any functions.
You'll see. Example of 8.22. So yeah, let's actually do one with a function. Check this out. Suppose we have plus over I, 2 less than or equal to I, 2 less than or equal to I, less than 5, body I squared. Right? Now tell me what are the possible values of I here? What are possible values of I in this range? 2, 3, 4. So this would be 2 squared plus 3 squared plus 4 squared, right? But let's not do that. Instead, let's use 8.22. So this equals, by 8.22, with, now check this out, with I equals F dot J, which in this case example is going to be J plus 2. Let's change the dummy from I to J with this function, I equals J plus 2. Now what does that axiom say? It says instead of doing plus I, we do what? It says we do plus J. All right. And now instead of this being 2 less than or equal to I less than 5, what do we have?
0.
Well, let's just it's 2 less than or equal to, so what is I? What is it's J plus 2, right? 2 less than or equal to J plus 2 less than 5. Body what? Body what?
J squared.
No.
J plus 2 squared.
Yes. Yeah? Is everybody clear on this? Now actually, we don't usually do some math, but let's do some math here. You know, this is plus J. Can you simplify this with the math?
0 less than or equal to
J
less than 3.
less than 3. 0 less than or equal to J less than 3. And we still J plus 2 squared. Yeah. Now tell me, what are the possible values of J here? What are the possible values of J here? What are the possible 0, 1, and 2? So if J is 0, 1, or 2, what is this? 2 squared plus 3 squared. That's the same.
It is like at one.
Are you with me? And it's the same, right?
It's equal.
Yeah, it's the same as what we had. That's what it's saying. It's the same. You can change the dummies. All right. Now, you guys, comes the biggie. What we're going to do now is we're going to prove this, and this proof is going to be on the test. And this is quite involved, but I think it's a really good exercise to. I think it's a really good exercise to get used to proving theorems with quantifications in them. Now let me see. Where's my? so we got worksheets today. So what we have now is yet another worksheet. Okay. It has the steps to be filled in. And you are going to fill in the steps for me right now. Okay. Now, on the, so what we have up here on the screen is what I'm handing out. Okay. And so you can take notes on here, but we're going to go around the room. But this time, it's going to be, yeah, this one now is not trivial. Okay. Now, but it's very nice. I think it's a very nice proof, and we're going to start using some of these previous theorems. Okay. So we have stated, the theorem is stated up there, provided y does not occur in R and P, and f has an inverse. We're going to do x star x range R body P is star y range R with x replaced by f dot y body P with x replaced by f dot y. Okay. Now the first one is tricky. So I'm going to actually, I'll go ahead and write this out. Star y, range R, x replace f dot y, body P, x replace x, or f dot y. So what are we doing? We're starting with the right-hand side. We're trying to get it to equal the left-hand side, right? So this equals by the 1 point rule. Okay, now who wants to go first? I'll help you through it. Now, what does that first hint say? Yeah, what is the 1 point rule? Oh, good question. What's the 1 point rule? Here, let's. Here.
X and E.
Yeah, let's go to the 1 point rule. Let's go to the one. Yeah. What does the 1 point rule say? It says that whenever you have an equals in the range, then that's P with x replaced by E. Remember we did an example of that? Are you with me? So now we're going to go backward. Okay, Ben. Okay, good, Ben. All right, so let's, yeah. So
It's going to be star y.
So it's going to be star y. Okay,
Range is the same.
star y range, and this part is staying the same, right?
Yeah, x replaced by f dot y.
X replaced by f dot y. Okay, good.
And then body,
But now body what?
star x.
Star. Very good.
Range x equals f dot y.
F dot y. Body
Body
P. Good. Good show. All right. Yeah, make sure you got this. Make sure. Do you agree? Look, if the 1 point rule says this equals this. Are you with me? The 1 point rule says this equals this. Yeah? Does it not?
Yeah.
Okay, so we're substituting equals for equals. We're substituting equals for equals, right?
You just say in body. That's just
Yeah, 1 point rule in the body. Yeah. Well, I give you the hints on the worksheet there, right? I'm just abbreviating up here, right? Okay. Okay. So now this one. Okay. So now what about nesting 8.20? Okay. So Kyle, nesting 8.20. So what is nesting? 8.20.
Okay. So we're going to go star x, y.
Yes. So this is star x comma y. So they're together here. Yeah.
Range R with x replaced by f dot y.
X replaced by f dot y. And
X equals f dot y.
x equals f dot y. Body
Body P.
P. Now, is everybody good on this? Does everybody see how that worked? Okay, so Josh, you're up. So this equals, by substitution, 3.84a, or sorry, yeah, 3.84a, not sorry. Okay, so let's go all the way back to 384a, 84a. Holy moly, now we're going to use substitution with our little Leibnizy thing. Okay, okay. So what does it say? If E equals F and E was replaced by E, that equivals E equals F and E was replaced by F, right?
We didn't do an example for nesting, did we?
Actually, we did not do an example. Actually, we did not.
What does that mean when you have two?
It's all the possible values of x and all the possible. Actually, we did do an. Yes, we did. We did. Yeah, we did.
But we didn't like do.
But we didn't do an example of this theorem. But we did an example of two. It was all possible. Actually, I even remember. I think Mason was the one who did it, right?
Yeah,
I think you did all. You did all the ones, all the possible i's and all the possible j's. Remember?
Yeah.
So that's what that means. That's what that means, right?
Well, how would you expand that out? Say,
You do it without. Well,
You don't want.
we don't. It depends on what the range is. I mean, you'd have to.
right.
So we're doing it in general here, okay? But Josh, you have to do substitute. You have to apply substitution 3.84a here, right? Now, what do we have as equal? What do we have as equal to in this whole
X equals F.
we have x equals this and this, right?
Oh.
Are you with me? Here we have x equals this and this.
Oh, what?
So 3.84a says, well, if x equals this and this, then it's the same thing as what? X equals this and what?
X replaced by X.
X equals that.
No, no. Look. If we have e equals f and e was replaced by e, that's the same thing as e equals f and e with what? Is replaced by f. See, if you have the 3.84a. 3.84a. Oh, okay, okay. No, okay. Well, here we have x equals f dot y and this expression.
With.
That's the same thing as x equals f plus y and what expression?
R with X replaced by X, which is just
X
R with what? Say,
X.
with X replaced by X,
x. Yes.
which is just R.
Hold on. That's the next step. Okay. Okay. We got it.
I'm just trying to make that sense.
Okay. Look. Here we have x equals
The
this.
reason it's confusing is because you're using, like, on the proof, you're using, like, X as Z. You're doing.
Yeah. Well.
E replaced by
Well,
X.
these
Can
are.
we do the textual substitution on that rule?
Well, this is just an expression, right?
Is it-
This is an expression.
Like what is
Yeah, so
The-
E equals X,
E is R.
Y is F dot
Oh,
Y,
no,
and then Z is
Yeah.
X.
This is e. Oh yeah. Unfortunately, we have an f there and we have an f here. That's kind of confusing. This is e and f, right?
Yeah,
And then
E
R
and
is
F,
the
and then
expression.
Z is X.
And well, this whole thing is the expression.
And Z
this-
is X.
Z is the X replaced by.
Yeah,
Yeah,
so
that's easy.
Yeah. So
that's why
it's
confusing me.
yeah. Okay. So it's yeah. Sorry.
3 X's.
Well, so what is this? So this is r. So Josh. So what is this? This is r with x replaced by what?
X.
Yes. And x equals f dot y body p. Are you with me? Now, Rochelle, you're up. Property of textual substitution. We actually did this a long time ago, but tell me, if R is an expression, so just imagine R is an expression and it has just a bunch of X's in it. And everywhere there's an X, you replace it with X. What do you have? Exactly. So what is this? Star XY body what? R. And X equals F dot Y body P. Is everybody good? Are we having fun yet? Is this good? Okay. Now, Mason, we get to our inverse definition, right? Now comes the inverse, right? So this equals, by definition of inverse, definition of inverse. So now what? So by definition of inverse, x equals f dot y is the same thing as what? Star x comma y, range r, and what does this equivalent?
Oh, y equals inverse.
Keep going.
X.
Yes, good. Y equals f inverse dot x. Are you with me? All right. Everybody has followed every step so far. Are you right? Is everybody good? Okay.
How did you just like come up with this?
Oh, yeah. You need to reproduce. This is what you will reproduce on the next test for me, but without the hints.
If we do it a different way?
No, don't. You can't.
Oh, yeah.
But without the hints. But without the hints. I dare you.
Why'd they prove this first?
Well, let's finish the proof. Let's talk about all that stuff later. Let's finish the proof. Okay. So now what's the next one? Nesting, right? We just did nesting. Look at all these ones we're using. We're using all the stuff that nesting, blah blah blah. Okay. The rest of the hint is on your handout. Okay. So okay. So now what do we want to have on the outside? What is it that we're trying to prove? You don't remember? Which one do we want on the house? We want the x on the outside, right?
Yeah, we want just the x.
Okay, so who was next? Kale? Okay, you're up. So this is going to be star x now. Because here we have an r and, yeah? This is 820. We should be looking at 8.20.
So then it'd be range r body star y.
Yes, very good. Hold on, slow down. Range r, body what?
Star y.
Yeah, star y, yes.
And then it'd be
Range.
the inverse f dot x.
Y, well, it's range this, right? Yeah. Y equals f inverse dot x. Very good. Body p. Very good. Okay. Good deal. You guys are rolling. Okay. Now, who's next? 1 point rule.
Double paren.
Oh, double paren. You're right. Double paren. 1 point rule. Cool. Good. We're almost there.
Star x range.
Okay. Say it again.
Star x range r.
Okay. Star x range r.
Parentheses p.
Parentheses.
Y replaced by f inverse x.
P, textual substitution, y replaced by
f inverse dot x.
f inverse dot x. Close this, right? Oh, wait. What? Hold up. What do you mean you're not following?
This isn't very intuitive.
Well, no. But do you see the step? Do you see the points?
Yes.
Do you see how each step?
I like it.
That's irrelevant. Okay. Now. Yeah. What is this now? What's the last one?
Because that's part of the proviso. Okay.
Yeah. Yes. A very good observation, Ben. It's part of the proviso. Yeah. Okay. So it's equals by textual substitution. What?
Well, we wanted it to equal star x, but range r, body.
What do we know about y? What do we know about
Does not occur in P.
Y does not occur in P.
What?
It's in the original thing. It's implied to not occur.
Y is not in P. Remember how we did these textual substitutions with a variable and the variable wasn't in there? You're just left with what? You're just left with that. So what is this? star X, range R, body P, boom! Okay, now you guys, you might as well start practicing. Now, you know what your homework assignment is for next time? Practice this without the hints. There will be no hints.
Because it looks like we're just pulling a rabbit that I have.
Yeah.
It does, but I tell you, here's that. Now that is a good point. I would like to address that. It looks okay. Hold on. It looks like we are pulling rabbits out of a hat all over the place. But let me tell you this: once you practice doing this solo, you will start to see. I mean, don't just rote memorize. I mean, you can start by kind of rote memorizing it, but what you'll see is you will see, oh, I have to do this because I need to do this later, and I have to do this, and I'm trying to get to here. So this is how I do it.
It'll be
So
like the other ones.
it'll be, and yeah, I rarely, I think this is maybe the only time I'll tell you which proof is going to be on the test. But this will help to sharpen your manipulative skills on how to use these. I mean, it would be murder to just rote memorize this. What you'll have is you will have your equation sheet. Are you with me? You'll have the equation sheet, and you will be able to say, oh yeah, we have to, you will remember, what you'll do is you will remember how to use your equations on your equations sheet to go through this. And then you'll see how you're heading towards what you're trying to prove. So it will become more intuitive.
Do we have to turn this in on Thursday?
No. There's no, it's just practice, yeah. You don't need to turn it in. No,
Test is next week.
and the test is next
Monday
week.
or Thursday?
I don't remember. Does anybody remember when the test is?
We should have
Thursday?
I was asking if the test is on Monday.
Okay? Good deal. Good. You guys did good work today. See you next time.